Right, welcome back. Today we're starting on this, well not today, I actually did some yesterday, but today we are continuing on with the big power supply for the Class A 807 amplifier, 2 monoblocks. So the power supply will go in here, and then there'll be 2 sort of monoblocks supplied by this with the 807s. That's the idea anyway, using those military connectors that I've got. So somebody built these oak, what do you call it, boxes for me, and I've basically chain drilled the big hole out and then got all my chisels and then done like a little recess similar to this one here on the inside. Not as nice as that one, but I ain't got a fancy damn machine. All I've got is fancy damn fingers. So anyway, where was I? Yeah, so this is the basic sort of how I'm thinking it should go. Yeah, but we should have more than enough contacts to play with. What we got? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And then these are for the heaters, big chunky heaters. So yeah, I chain drilled the hole out of the wood, and I've just made a plate, basically freehanding it with the, I've just got the plate, I mark it up with a pencil and spinning round, square, cut it by hand and eye with the angle grinder, and then I just true it up with some files. Just using that complicated device over there, which is called a chair or some sort of steppy thing. And then I've just roughly marked out where I think these things ought to go. IEC connector, fuse, big connectors. And then what I shall do, I shall go and mark those out in a bit more accurately with a square and all the rest of it. And then I've got some holes to drill out. Well, here that will be chain drilled out, you know, lots of little holes. In fact, I'll show you how to do that if some of you will know, most of you will know. Some young guns that's starting out may not. That's just a simple hole, or is it? No, it isn't. These are tricky to get right actually, in that they've got flats so that it doesn't spin. So you have to, well in fact that's only got one flat. Okay. So what you have to do, you have to basically drill the hole undersized and then file it out a bit. Hard to get really perfectly right, but practice makes perfect. Right, so I shall crack on with that, or going on in the same vein. I got the old coil winder out yesterday and I needed a choke. So before I was using these chokes, which are really nice, or one of these chokes, which is, it's 80 millihenries up to 3 amps, which is not quite, I don't think, the right sort of thing for application. And then I thought, right, okay, so we need a bigger choke. Looked online, Salter, etc. Ooh, 200 quid, 250 quid. So instead of going and sitting down for a day and doing loads of calculations and figuring out what inductance I want and all the rest of it, going on the principle that the bigger the better, and sort of working with what I have, I found a transformer which was 240 primary to 30 volt secondary, pulled all those windings off, put the bobbin on the coil winder, got some sort of appropriate sort of size wire which should be good for about half an amp. I've got some testing to do, and then I just basically, no calculations, I just wound loads and loads and loads and loads of turns on. And how many turns did we end up with? 2,300. We ended up with about 2,000 turns. I measured this yesterday using the simple inductor in series with some resistors, and then putting a sine wave in and measuring it that way and working it out, and I worked out that we've got about 30 henries there. But it was more of an experiment to see, right, let's just bugger the maths, let's wind a load of bloody turns on a bobbin and see what we get. So here's all the rolls done. So basically what I did, I use my biggest punch, which is 30mm, to get all 3 holes. Then I use the step drill I've got, which goes to 32mm to do all the holes. So they're 32, this one is 35. So I did use a step tool just to take them all up to 32, and then I just use me rough file to file out the 35 one, and to just tidy up these holes here. Then I just used that to just take off the burrs, as I've done in other videos. Done the fuse, marked out a flat, drilled it out to 16mm, it was about 17mm. Then I just used a small round file to take it out, and a flat file just to get the flat. And pop it in one-handed, and as usual it's not quite right, but once that is tightened up with a crinkle washer on it, it'll be fine. That's a good point. I've just, oh no, there it is, there's the nut. And so next we've just got the IEC socket to do, and basically these measure about 1 1/10", 1 1/16 by 3/4, and then they've got these little corners on them. I might not even bother with them because it's just as easy just to cut the old bloody thing out. So to do that, you do what you call hole drill, and that's just a matter of memory when to get, well no, not the memory, the camera's fucking about this time. Right, you need a good sharp drill obviously. Nah. Well, that's not a brilliant drill either, is it? Try that one, try this one. Now I've got one decent drill here. Chucks on these Makita drills are shite. Well, the older ones they are anyway. Right, and you just go around doing that. Whoops. Sort of walk it towards it, if you see. Right, I'm going to do the rest off camera because I need to drill it a bit oversized, and it's really hard doing it like this over the bloody camera. One moment. Right, as you can see I drilled that out not very well. So I'm used to working at a different height. When you sort of drill the holes, you don't want a really powerful drill. Don't do this, or if you're going to do it with perhaps a clutch on the drill a bit, sort of flex, you know, not hard on. Right, and for the next ones, when I can find my screwdriver, I want a reasonably sharp screwdriver. Remember, it's only aluminium, another form of cheese. Whack, whack. You don't want to do this too hard, by the way, otherwise you'll distort the metal around the hole. Not far off, is it? There. Yeah, try not to hit it too hard. I usually drill it out a lot better than this, and there's no need to be pounding on the bugger. Right. Now that's out. Matter of, you want a coarse file for aluminium really, but this is the coarsest one I've got. I don't bother with a vice or anything like that, just a block of wood, or usually on my knee. remembered I got this really rough square file, which is good for this. Yeah, so now we've got the rough sort of thingy, the rough shape. In fact, I'm going to do it on here because you can see it better. See, we're not too far off, and we've done that with the rough file. We start cleaning it up with a finer file now. What I do with aluminium, use a bit of wax, an old candle, bung a bit of wax on it. I'll stop the file getting too filled in, hopefully. Another check. See, that'll go through just about now. I'll just clean these up. Upside down. There you go. Didn't take as long at all, did it? About what, 3 minutes? 5 minutes? Nah. Obviously it don't look very nice, but we'll go around with a Stanley knife to clean that up. I'll go there. Well, show the whole lot and show it. Get out of it. Where's the other one? Unos, dos, tres. Sort of like that. And then we'll come over here. Hold on. I'll come back for that. There we go. Don't look too bad at all, does it? Right, it's some days later, and today we've been mostly hacking about with old hacking. Today we've mostly been hacking about with chisels. So we've got the back panel in with all our bits and bobs on. So we've got one heater for one monoblock. So this is one socket for one monoblock. So let's say heaters for the 807s, heaters for the first stage, replicated here, left right channel, and then we've got a 9 contact socket here, which should give us roughly, if I calculate it right, we should have HT, screen grid supply, ground, bias, and a few other bits and bobs. I'm sure there'll be a few other bits and bobs, so more than enough to meet our needs. Got our IEC in with our fuse. And then what I've been doing today, I mean, I can't believe this has taken me just about all of today. And look at all the tools everywhere, general chaos, wood everywhere. So what I've had to do is put this switch, key switch on, but the problem is that the key switch, one moment, the problem is the key switch, we've got about ½ inch here, and then we've got less than ½ inch because the locking ring has got to go on there, so we've only got about 3/8. So to try and do this sort of nicely, because we've got about an inch, this wood here, the wooden frame thingy chassis is an inch. Obviously that means what, we've got 3/8, we've got to knock off 5/8 that we've got to take off somewhere. So I've recessed a 32mm down there with the old drill there. Recessed that with a 32mm bit. Made a brass, what would you call that? A big brass sort of washery thing. And to do that I used, what did I use? Drilled a hole and then used my punches to knock a hole in that. And I basically cut it out with a good pair of scissors and then filed that down to size. I've got to basically shine all that up, clean all that up. So recess, that goes in there. I mean, it's not pretty, that isn't quite flush, but this is where you need your fancy Dan tools. This is where having, you know, proper tools does the job. And then you're hacking about with chisels is that abortion there. I mean, it isn't pretty, but it works. The problem is obviously trying to get in there with chisels into a confined space. It would have been far better if I'd have known beforehand, before these were knocked up, where everything was going and everything, but I didn't. So whatever, it is what it is. I shall try and clean it up a bit better than that, but I mean, it's not pretty. And then we've got some more hacking about to do when I can find a little light. Here's a little light. So here's the light, and as you can see we've got even less material there, so I'll probably do the same thing, or maybe not, with a brush washer. But the original, oh, the devil, there we go. Right, so the original sort of fitting went in like that. Now then, if we was to do this with like a sort of thin washery type thing, then that means we have got to take out, what is that? That's about, what is it? It's getting on for about 1.5 inches, so that means hacking about 1.5 inches square out to a real deep depth. It's just not really a good idea, that. So what I'm going to do is to drill a hole, pop that in, and then the big hole, well, we don't really need to, we just need to drill that hole to that depth. I can more or less screw that into the wood maybe, or stick it into the wood, and then all we need then is like a hole for this holder to go in. And then somehow I'm going to have to alter this older thingy and find a way of mounting that on there. We're still messing about with this power supply, and here's a rough schematic of said power supply. There'll be other bits and bolts involved, but this is basically it. So basically we've got, this is our big toroid, which is over there. We've got two high voltage windings. We've got one here that gives us 350 volts DC here, and then we've got another one, depending on how we configure it and whatnot, to give us about 200 volts. So starting at the bottom one, we've got, if you look, there's two big resistors, and those are those resistors there. And this acts as a soft start. So what happens is, when we first power it up, this big resistor here will limit the current going into this big 820 microfarad cap. It will slow it down, giving the heaters of the valves on our amplifier time to warm up. And then at some point we've got a relay going across that will switch, shunting out this big 1K, and we've got the exact same sort of arrangement up here. Same thing, reduces the current to 820 microfarads, choke, 820 mic, forming a pipe filter, 1 amp fuse, 1 amp fuse. This sort of arrangement allows us to use a slightly lower fuse, because we haven't got this inrush current. Also over here you'll see we've got a regulated power supply. So this will be our 300 volts going to our screen grids of our 807s, and I'm going to regulate that using a valve regulated power supply. We'll get onto that in a minute. So first let us have a look how we're doing the delaying. On eBay the other day I bought 4 of these delay relay valves. Here's one here. This is a B9A version of this. And what you've got basically, you've got 2 bimetallic strips in there, can you see? Oh right, so you've got a bimetallic strip there with a little heater coil on the back of it. If you know your sort of bimetallic strips, basically we've got 2 dissimilar metals that when heated will bend at a different, will stretch, will, what's the word, stretch? Expand at different rates, meaning that they're bonded together, so when you heat them up, see that bit of metal there, that will bend over this way, and that will basically then form a switch. And we've got the same sort of doings here. So what happens is we warm this up. After say 20-30 seconds that switch engages, switching on this relay. This relay then cuts the power to our delay valve, switching it off. And then this is basically the circuit that we've got. So we've got a sort of DC supply going in there. I've got 12 volts here, it isn't. That is all working like that. The heater, one of the heaters for the, one of the legs of the heater for the delay valve goes through this switch here, which is part of this relay. This relay has got 3 switches. So we've got one switch that switches off our delay valve, one switch that shunts a 1k resistor, the other switch that switches a 1k resistor. You see? So when this whoop, switches that switches that on, that's then switches that switch, turning this off. Let's see it in operation. So I've thought about this. I was going to wind another winding on that, or use a separate transformer to make a linear power supply, but I thought, look, I've got loads of these bloody where do you call it, switch mode power supplies. Got one at 24 volts. We need 21 volts to switch this relay. We need only 6 or 8 volts to switch to heat this delay valve. So what we've got, as you can see, is a resistor. And here I'm using 200R resistors in parallel to give us about 50R. We only want about 40R really. When I switch it on, you'll see that that's what's reading across one of these big resistors. Here, this will have the voltage of the delay valve. So let's switch that on and start counting. You ready? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27. Come on, you bugger. 28. What's going off? Have I got something wrong here? Oh, there we go. So you see, that's shunted this 1k resistor and turned the delay valve off. That's our delay soft start. You can do it with, before I've used transistors and an RC filter, an RC time constant thing. So you've got a resistor charging a capacitor. Because of the resistors there, that basically dictates how fast the capacitor charges. once that capacitor is fully charged, that basically switches the transistor on. But I wanted to do it with valves, and I know about these valves from the all these tech scopes have got them in. In fact, this little one is out of Tektronix Scoop 545B. So there we go, that's going to go in our power supply. Just takes a little while to go off. There we go, you can see our resistor's back in now. So that's that, and then next I need to show you a regulated power supply, and we'll do that in a second.